So you can download the book from here, which gives you some more background material if you're interested in it. I take academic dishonesty very seriously, so you should not try and pass off anything as your own work that you didn't actually write yourself when you submit an assignment, a project, a midterm, or a final exam. With any object, with any material that you submit for grading, you also have to submit the honesty declaration, which basically states that this is all your own work. If you work together with other students, or you discussed some ideas after class, or used some open source software from the internet, then that's okay. You just have to tell me, you just have to cite it correctly. In that case, it wouldn't be academic dishonesty. It would not be a case of plagiarism. You would just not get the credits for, or reduced amount of credits for, the code that you copied or the ideas that you copied. So here it says, I've worked together in a group. So anybody that you discussed your assignment with, you need to list here. You state that you implemented the program by yourself, that you ran the tests and the experiments by yourself, and the results, you didn't fake them or change them, and that you wrote the report for yourself, and then a list of external sources that you used while preparing your exam, your material. And I just put as an example my own lecture slides in there, saying that you used those while preparing your project or assignment. Now, registration, make sure that you have the right prerequisites and the right registration information. That's important, especially for our foreign students from Germany that may be taking this course, or other students. I won't have any chance to check that myself. Okay, we have another message. And reinforcement learning, and join the channel. Right now I have to server mute a couple of people. Okay. So do not try and pass off anything as your own work that you didn't actually write yourself. If you did use help or discuss it with somebody else, that's okay. You just have to cite it properly. And then registration, yes, make sure that you also have all the prerequisites, and then you're officially registered in the course. Major disruptions with the COVID pandemic going on, still being a concern at the moment, and what other events may occur in the future. There may be a reason that we have to adjust both the course material or the course grading, in which case I will inform you. So let me add Jihan as well. Okay, good. So are there any questions about the course page, the basic organizational structure for the course? So any questions so far? If not, then good. I will proceed. What I want to do next is do the introduction for the course so that we get to know each other better, a little bit better. So I will do an introduction for myself, and at the end of after my introduction, after I finished with my little bit longer introduction, I will ask you to provide your name, your university background, where you studied, what degrees you have, and what your degree you're currently pursuing. So, for example, I studied at U of M, did my bachelor there, and then now I'm first year master student at NTNU. Then the programming experience that you have and the IDE that you use. Then your hobbies, and lastly, why you want to take the reinforcement learning course. Okay, so after my introduction, you will all in turn, one after another, give a little speech. And I will start with my own introduction. I will start up here. See if we have any other students coming a little bit later. Okay. So my name is Jackie Baltes. Here's my email. You can always reach me via my NTNU email. And a little bit about myself. So I received my PhD from the University of Calgary in Canada in 1996. At that time, my dissertation work was a simulated kitchen robot that could make many dishes and drinks for you. That problem in itself seems trivial for a human, but just the planning that you need to do is quite extensive. There's many steps that you need to execute in order to be able to achieve a particular goal. So for example, to make a cup of water, the robot has to drive to the cupboard, open the cupboard, pick up the cup, put the cup down, close the cupboard, pick up the cup, drive to the sink, put the cup in the sink, turn the faucet on, wait, turn the faucet off, pick up the cup, drive to the microwave, put the cup on the table, open the door of the microwave, pick up the cup, put the cup in the microwave, close the microwave, turn the microwave to 1 minute, wait, open the door of the microwave, pick up the cup, drive to the cupboard, put the cup down, which now is hot water, open the cupboard, open the tea box, get the tea box, and then put the tea box down, open the tea box, pick out the tea, put the tea in the cup, close the tea box, put the tea box in the cupboard. So you can see there's hundreds of steps, even for very simple dishes. At that point, you just have a cup of tea. If you want to make a full dish, like Taiwan Neo Ro Mien, then this would be many more steps. The problem is that in a sense, there is an algorithm that seems to work and will allow us to solve those problems. I could just have the robot start and try all the possible things it could do, and then keep doing that. Eventually, he will have reached a goal state, which is holding a cup of tea. But the problem with that idea is that the number of steps that you need to execute, let's say 100, the possible other things you could be doing either grows infinitely or extremely quickly. Even if you only have 2 choices, then the number of possible paths that you have through the tree that is spanned, in that case, would be after the first step you have 2 possibilities, then 4, then 8, then 16, then 32, then 64, 128. So after 10 you have 1024, 1,000 choices. So those you can search through very quickly on a computer nowadays. But if you have 20 choices, then you're looking at 1 million 2 to the 20. Yeah. If you have 30 choices, then you're already looking at 1 billion. So if you have 100 choices, it will take thousands of years before a robot can figure out a plan to make a cup of tea. And then this, what's called combinatorial explosion, this exponential complexity of the problem, makes it intractable for anything but very small problems. So reinforcement learning is actually one idea or one approach, and a very successful approach at the moment when combined with deep learning, in order to make that kind of enormous search tractable. But in 1996, we used the full complexity approach, and then tried other approaches for trying to reduce, to make the program run faster. And my particular contribution was the idea of using multiple problem-solving strategies, trying to combine them on a single problem. So there's various ideas that you could have in order to reduce the size of this enormous search space. One idea, for example, would be abstraction. When you think about it, all that business with opening and closing doors are sort of low-level details. It would be more efficient if you just think about making tea at a very abstract level first. So you would say, oh, I need a cup of water and I need it with hot water, so I can either heat it up on the stove or I can heat it up in the microwave. Those were the two things that I had in the kitchen that would be able to heat water. And then I need to put the tea in. At that point, I don't really care about the state and the position of the cupboards, because I can work that out once I decide if I want to use the microwave or if I want to use the stove. And then there's different things that I can check. For example, if I plan on using the microwave, then I can make sure that the microwave is turned on, that it's plugged in. If I want to use the stove, I can make sure that the gas, that there's enough gas to boil a pot of water, things like that. So as I plan, I add more and more lower level details. This is a very powerful problem solving strategy, one that humans use with great success, but we also use other kind of problem solving approaches that help us solve these kind of problems. So for example, case-based reasoning would be another way, another approach, because if you know how to make tea with milk, then to figure out how to make tea with sugar is actually not that much different, right? So you can use your recipe, you can use your plan for making tea with milk, and then change it so that the end result is tea with sugar. That's another kind of problem-solving strategy. There's also macro operators, like grouping things together that co-occur very often. So for example, putting a cup into the sink, turning the sink on, waiting, turning the sink off, picking up the cup. That's a very common operation, so you may group those together. And in my view, one of the problems with the way that we approach AI, and even today, where everybody simply applies deep learning and then hopes for the best, is that we just use one approach. So at mid-1990s, people would choose abstraction levels, and then they would solve the entire problem that way, or deep learning, or some other method. But the problems are so hard that actually different parts can be solved more effectively, more easily, using a different approach. And humans are very good to sort of have a fuzzy idea of what they're trying to achieve, and to be able to combine these different problem-solving strategies on a single problem without having to start from scratch. And AI systems don't really do that at the moment. AI systems, researchers pick one method, deep learning, and then they apply deep learning, or transformers, then they apply transformers. And they try and solve the entire problem that way. We have pushed the boundary. They have certainly performed very well. But for many of the complex problems, in particular problems where the rewards are temporarily. There's not many rewards, and they're spaced apart, where you don't seem to make much of progress towards the goal as you execute many steps. Deep learning is not sufficient to solve these kind of large planning problems. Let's try this. So after I got my PhD, then I went to the University of Auckland in New Zealand, where I started working as a professor. At that point, I realized that, in a sense, before I was quite happy with my dissertation, but when I thought about it, I realized that many of the things that I did in my planning system, like pick up a cup or turning on a faucet in a kitchen, is something that is trivially done for humans, but actually to build a robot that could do that in the real world is extremely hard. And then the question would be, well, if I had made other kind of choices, then maybe the system wouldn't have worked so well. Maybe I was cheating in a sense, and that, of course, then meant that the planning system that I did, even though it ran faster compared to that of other people at the time, maybe theirs would have run faster if we had made a different kind of simulated work. So I thought that for AI to be meaningful, it has to be embodied in the real world. And there's also Meredith paradox, sort of saying that anything that you think is easy to do on your computer turns out to be really hard. Anything that you think should be hard, require a lot of intelligence, turns out to be surprisingly easy. At the moment, in 2021, we're at a state where we have computers now that can beat the world champion in any kind of opposing player complete information game. So chess, checkers, Go, which was the last one, the most complex game that sort of computers were working on. Nowadays, the computers can beat the human world champion in any one of those games. But we don't have a computer that can detect mother and father as good as your 2-year-old brother. The kind of things that you take for granted. We don't have computers that can plan motions as accurately and balance as well on uneven ground as humans can. Going hiking in Taiwan is a lot of fun, but it will be decades before we have robots that can climb up the same mountains, in spite of the great improvements that Boston Dynamics have been having with their hydraulically operated Atlas robots and mini Spot robots. Those are actually have direct drive, not hydraulics. So that's why I got interested in robotics when I joined the University of Auckland. The idea is to study AI. We need to look at the embodiment and the problems that agents face in the real world. I also got interested in robot competitions, because I think those are very good for motivating research, guiding teaching, and also as benchmark problems. We can actually compare different approaches in AI and see how well they work in the competitions. In 2002, I joined the University of Manitoba in Canada. That's a picture of our administration building, and it looks like a beautiful day, right? Clear blue sky, a little bit of snow on the ground, but the temperature can be very cold. It can go down to minus 40 Celsius. In fact, 1 year with the Sojourner robot being up on Mars, the temperature with wind chill in Winnipeg was minus 56, and the temperature on Mars was minus 54. So it was actually warmer on Mars than in Winnipeg. It's the city that has the coldest temperature with more than 750,000 people. And then in 2016, I joined the NTNU here in Taiwan. So sometimes I feel like I moved from the coldest place in the world to one of the hottest places in the world. Because Taiwan can be very hot and humid. Today is not too bad, I guess. When I joined the University of Manitoba, also I changed my research direction from wheeled robots to humanoid robots. And I've been continuing working on humanoid robots also here at the NTNU. So some of the robots that we have in the lab at NTNU at the moment, we have the small Darwin OP2, OP3, OP1 robots. They're about 45 centimeters tall. The robots are controlled by fully autonomous, and they're controlled by an onboard PC. The robot recognizes its environment using a webcam. Also has a 3-axis gyroscope, 3-axis accelerometer built into the torso in order to be able to balance. And also has a microphone and a speaker, so it can talk to people and listen to commands. We've been competing at various robot competitions. The most important one for us is the Federation of International Robot Athletes competition, Robot World Cup. It was last held in person in 2019, where our small robots won second place in the all-round competition. Now the all-round Eurocup all-round is like a decathlon. It's a single robot that has to compete in 10 different events. I think that's an important characteristic. I believe for intelligence, the versatility and generality of your algorithm is more important than the optimality, because humans are unable to solve many problems optimally, but in contrast to robots, they never ever do the really stupid things. So we have machine vision systems, for example, at various airplane manufacturers, Boeing, Airbus. Then you can put a workpiece in front of the vision system, and the vision system can tell you that this particular rivet hole is off by 1 millimeter, or it's not quite round enough, it's more egg-shaped. That's something over hundreds of thousands of different rivet holes in order to build a plane. That's something that humans can't do. That kind of, if you're looking for exactly this kind of hole on exactly this kind of workpiece, a machine vision system can do a phenomenal job. However, if you put a pink elephant in front of the vision system, it will still try and detect rivet holes and tell you where the holes are and where they're wrong and things like that. Whereas for a human, this would be obviously immediately detected as not a workpiece, and that something seriously went wrong with your setup. Also, our soccer playing robots, or our humanoid robots in general, for when you're trying to play soccer, one of the biggest challenges is just to make sure that the robot actually stays on the playing field and doesn't walk off the field or doesn't walk into a wall 3 times in a row, 4 times in a row, 5 times in a row. Humans would not do these really stupid movements, wouldn't really behave in a really stupid way. But computers don't have this compunction. So in a sense, I actually believe that artificial intelligence is not about doing the optimal thing, but it's about never ever doing the really stupid things, which sets human intelligence and artificial intelligence apart. So we also have 80 centimeter tall humanoid robot with slightly more degrees of freedom. You can also see it has articulated hands, articulated grippers, so it has fingers and a thumb, so it can do more interesting manipulation tasks. We've been using this particular robot, for example, to do magic tricks, where the robot fully autonomously performs magic tricks. That's quite a nice, challenging problem. And this robot also performed very well at the last FIRA World Cup, winning first place all round and also winning the magic show. We have a 1.3 meter tall humanoid robot that was designed mainly for playing soccer. So it doesn't have many degrees of freedom in the torso or the other joints. And it competed at the RoboCup competition, the largest intelligent humanoid robot competition with more than 2,500 participants every year. FIRA is smaller, about half the size. We also have our wolf and bear robots, which are our largest humanoid robots and also heaviest, 42 kilograms, 137 centimeters. They use 2 computers instead of a single computer, have a larger array of sensors, including 3D RGB camera and LiDAR sensors, as well as force and torque sensors in the arms and the legs of the robot. So for the robot competitions, the FIRA competition consists of several leagues where we have drones that are racing or trying to do a disaster scenario. So a building on fire, and the drones are supposed to fly there and then figure out where the fire is and direct firemen to the right place. We have soccer playing robots, both on a small playing field and a large playing field. Wheeled robots playing soccer, and there's also a youth competition for under 14 and under 19-year-old participants that are mainly line followers that also perform various sports events. So I'm going to show a couple of videos of our robots. So for the Euro Cup, a single humanoid robot has to compete in here weightlifting. So the robot has to walk up to the bar. So here for weightlifting, we didn't just want to measure the power in your shoulder joints, but this is actually more a balancing problem. The robot has to recognize the bar, then pick up the bar, then walk towards the lift line. So now the center of mass changed, right? Because we add a lot of mass to the robot, the dynamics of the motion changed. Now he has to lift the bar above the head. Now the center of mass is much higher, so the whole walking gait is more unstable. And then he has to cross the finish line. Okay, so nicely done. This was our robot, I think 2018. There's also a sprint event. One of the nice things about using sports in benchmarking of the robot of the AI and the walking gaits and the motion planning and the stability is that you can actually see the progress. So when we started, the 3 meter forward alone would take, actually we couldn't do 3 meters. We started with 2 meters in 2002, just walking forward, and it took about 2 minutes. And then about 2015, it took a minute and a half to go 3 meters forward and 3 meters backwards. And now the fastest robots can do it in 25 seconds. So you can sort of see the progress of the field throughout the years. So the robot, he has to walk forward and then turn without turning around, walk backwards, because that is actually quite a bit harder than walking forward for the robots. Let's see what other videos are interesting. We have a marathon. So there the robot has to be outdoors and walk for 400 meters following a path. And now this is a little bit older video. In the new version, there's actually no path, but just signs like arrows, point left, point right, go up, go forward, so that the robot needs to be able to read the signs. But just by being outdoors, you can see it's much more difficult from a vision point of view because you have shadows and sunlight. So your detector for the path has to be very accurate. Also, it's much more uneven than a carpet in an office building, or like here you can clearly see the shadows. We also have basketball. This is one of my earliest humanoid robots, but I still like this approach. We used the mobile phone, a Nokia phone, on top of the robot to be able to act as the brain of the robot. So here the robot is walking up towards the basketball to pick up the basketball. So it has to lean forward because we didn't have a sensor to move the head. And then it was quite tricky to get a motion so that the robot can actually pick up the ball without dropping it. This needs to be very precise, so we had to implement a visual servoing approach where we look in the camera where the ball is and where the hand is to make sure that they're aligned. And then we had to move the ball out of the way of the camera, otherwise the robot was not able to see the rest of the playing environment anymore. And here is, we have also worked with larger robots. You may have seen it downstairs in the 3rd floor. So we're trying to build a robot that can compete at the Olympics in archery. And right now we can shoot this on this particular distance. You can move the target and the robot and it'd be able to hit a bullseye. This is quite encouraging, but this is about 15 meters. When you want to compete at the Olympics, you have to shoot over 75 meters. That is one of the problems is we don't have enough power in the shoulder joints to actually move the bow and arrow and make sure that we can hit the target or just shoot the arrow for that kind of distance, never mind actually hitting a target. And then I mentioned before that we have also a magic show competition. So here are some of my students running a magic show in the lab with our Thormang robot. Where is it?
Welcome everyone, I am Thormang. Today I am going to show you a magic trick that I have learned recently. As you can see, there are 3 paper bags in front of me. Later, I will put this wooden piece with a sharp nail into one of the paper bags. And then swap around the position of the bags to make sure we will not find out the bag is empty by feeling the weight. So I prepared 2 wooden bases without nails. Please help me put these 2 wooden bases into 2 paper bags and close it.
So the research goal here is detection and manipulation of soft and formable objects. So the paper bag is not
Student, please ask an audience member to examine your nail and make sure it's real. So, audience volunteer, can you explain the audience if the nail is indeed real? Okay, thank you. Student, please place the nail inside the last bag and close it. And everyone, please pay attention and remember which bag you need the nail. Now, I need another volunteer. Thank you for volunteering. Now, do you remember which bag contains the nail?
Now we're going to shuffle them, but they're all locked because they have very fine vision. You can detect where the bag is.
The unit is on, right? To make sure that I will be able to know which bag contains the nail, the student will start swapping the bags around. When I say start, the student will begin, and volunteer. You can shout out stop anytime you want.
So you just need to say stop.
Let's start.
Stop.
Okay, now I need some time to feel where the nail is.
因为我们老师他是动手，然后就跟我们说一个礼拜之内可以做到魔术，所以我们就让机器人知道说一定会在中间。因为刚刚你看到是在中间没错嘛，那就麻烦等一下的时候帮我们讲错或有。
哦，OK。
就是选择的时候，因为他等下会说哪一个袋子里面没有这个甜点没有甜点，然后他会让老师去按这个没有甜点的袋子，所以待会就不要一定要老师选中间。
See, now they're all
I am 100% sure the nail.
joking that I don't speak Chinese.
Much more interesting, Jackie. As the supervisor of your lab, do you believe in my talent and your students' ability?
Not so much my students' ability, but their hope to graduate.
Oh, I am happy to hear that. Since you pressed out so much, we can raise the stakes. How about we use your hand to press down the piano?
I'm not so sure about that. It was supposed to be green hand, not white hand.
Please give me your hand, Jackie.
Okay.
Volunteer, choose a bag you think there's no nail inside. Left, right, or middle. Choose wisely. You wouldn't know the nail, Professor Lander, right?
Left.
Okay, left.
Okay. You shut up on this.
Jackie, don't be a bit nervous, don't you trust me? I am the only hope of graduation for your students. And I won't disappoint you, trust me. Hey, volunteer, what's your next choice? Left or right?
Right.
Okay, right.
So now they all think the bag in the middle has
What just happened?
Finish your reading.
Oh, okay. So just a glitch.
Okay, this one?
Yes. Okay.
But I don't think it's a mistake. Jackie, do you trust me?
No, not really, no. Just reboot it.
Why? I only made one mistake.
Yeah, but you see what
Give me another chance.
I only have 2 left. We forgot to put the cap on. That's the problem.
Yeah, not you. Don't be that scared. I know what I'm doing. So, you might be really curious where the actual nail is, right? Jackie, please help me to check what is in the bag.
So this trick worked particularly well because it was based on the fact that I don't speak Chinese and my students were trying to trick me. And then we surprised everybody, which I guess is the hallmark of a good magic trick. Okay, so that is the introduction for myself. Now let's hear it from you. So for myself, name Jackie Baltes, university background will be PhD at the University of Calgary. My programming experience, more than 30 years using different programming languages. Last 6 months, for example, I checked, or I sort of tried to remember, I used Python, C++, Go, and Java and TypeScript. The IDE that I use, mostly Visual Studio Code and Android Studio. My hobbies are various sports and also trying to learn Chinese, but as you've seen in the video, unsuccessfully, so my students can fool me easily. And why I want to take the reinforcement learning course. It's a hot topic in machine learning and AI in general at the moment, and is a general approach applicable to many different problems. So this is my introduction. Now we're going to go through the list, and I'm going to ask you, each and every one, to please introduce yourself. You can turn on the camera and also make sure that you unmute yourself. So let's go with number one first. How did I do that last time? Okay. Oh. So 610754041H, please unmute yourself. And introduce yourself to the class. So we go from top to bottom on the just on the list, no particular order. Okay, 610754041H. You are unmuted, but I cannot hear you. Maybe try and restart your Discord. Works better in the So 41H, if you please try and restart your Discord app. If you cannot talk, then you can send a message to this channel. Okay. Okay, then just type your message. Or your introduction. NTNU student, yes. Can write Python and C, yeah. Okay, and what are your hobbies? Oh, play badminton. Good. Okay, thank you for your introduction. Next up, we have 49H. And now I have to unmute you. Hello?
Hello.
Hello?
Hello.
Yeah, I can hear you. Please introduce yourself.
Hi everyone, my name is Lai Jiaze. I educated from Bachelor of Electrical Engineering in YBU. My hobby is play basketball and watch NBA. I can write C programming and C++ programming.
Okay.
Thank you, everyone.
Why do you want to take the reinforcement learning course?
Because my research attention artificial intelligence.
Okay.
So,
okay.
Yeah.
Thank you. Thank you for your introduction. Now, after your introduction, can you please mute your microphone?
Okay.
Yeah. Thank you. So 610-750-56H, you're up next. Hello? Yeah, I can hear you.
Okay, so my name is Li Wenyan, and I'm graduate from the Chang'an University, and my college major is electrical engineering. So I don't have the programming experience. I have less programming experience because my college is about I'm doing the semiconductor manufacturing. And I have my internship is about a little bit deep learning and IoT, but I'm still not very good at programming. And my hobby is sports, and I like basketball and badminton, and I also like watching movies. And why I want to take this course is because I'm very interested in the machine learning and the AI area, so I take this course.
Yeah. And which programming languages did you use during your internship?
We are doing the Arduino.
Arduino, Sketch, yeah.
Yes. And I learned a little bit the microprocessor, so it's using the C++.
Okay, yeah. Thank you. Good. Then next up, 610-750-63H. Hello.
Hello. Hello, everyone.
Can see you.
My name is Wang Tang. I graduated from Yangtze University. Major WE. In my university, I do research about robots. Use RoSense camera and Jetson Nano to Slam and graphing the map. So my So my hobby is basketball and League of Legends. Thank you.
Okay. And why you want to take? Oh, you told us already. Yes, for your projects. Okay, good. Thank you. Next up, Loki Singh. And I will have to unmute you. Okay. What happened to you, Loki? Weird, doesn't show up as a member. Loxing, can you introduce yourself? Are you there? No. Okay, then we'll move on to Jackie Wang. Oh, wait, no. I was trying to tell. Okay, yes, we move on to Jackie Wang. Please introduce yourself. So what will be your ID? Send message. Oh, okay. Yep. Okay, good. Can you say something now? Jackie Wang? Because I just heard you, I thought. Okay. Never mind. Then next would be Jasik.
Hello? Can you hear me?
Yeah.
Okay. Good afternoon. I am Jasik Jung from Korea. I am PhD candidate in the ERC lab at NTNU. Jackie Bartes is my professor. I finished my master's degree at Korea University in Korea. Our lab is developing humanoid robots, including hardware and software ourselves. For mechanical design, I am using 2D and 3D tools such as CATIA and AutoCAD. For electrical circuit design, I am using ORCAD and PASS. I am using Python, C, and C++ with Visual Studio Code and Arduino IDE to develop our humanoid robot. And I like playing basketball and watching NBA and sports games. I like watching videos related to robotics as well. I need to learn reinforcement learning more and more for my dissertation. The topic of my dissertation is simple for balance control of humanoid robot in a highly dynamic environment, which is a balance board. I will solve this problem using reinforcement learning. So I am taking this class again. Thank you.
Okay, thank you. Basic. Next up, Jihan.
Hi.
Hello.
Hello. Can you hear me?
Yes, I can hear you very well.
Yes, hi. It's my pleasure to introduce myself to you guys. And I'm Jian, and a member of Team GST team here. And my major is media art. And I have been studying at NTNU ERC since 2017. My hobby is making Korean food, and I am a little late because my Chinese class ended a while ago. I'm not familiar with the programming, but I applied because
I thought it was an essential study in my life. Thank you for listening to my short story. This year.
Okay, thank you. And next, Gente.
Hello,
Hello.
and my name is Wang Rende, and I'm a master student from NTUST. I major in computer science, and I use Python to do my graduate project. And I also know a little bit about C++ and Java. And the reason why I want to take this course is that I want to learn this technique to see if we can apply to my thesis project about recommender system to provide me another angle about machine learning technique. Yeah. Thank you, everybody.
Okay, thank you. Next, Jimmy 0824. Hello? Oh. I could hear you just a second ago, but now you muted yourself. Yeah, hello. Now I can hear you.
My name is Cai Zhongling. You can call me Jimmy. And I'm graduate from Chang'an University. And I'm major in electrical engineering. And I have about 1 year programming experience. And I use Arduino to I use App Inventor to communicate with Arduino in C, and this is the my project in Junior. It's a Arduino card and can have velocity control and have GPS map. And I also have another project for using LiDAR to make a support device to protect from elder fall down. And my hobby is play table tennis and watching animations and listen to music. And why I want to join this class is I'm just undertaking my seniors robotic arm, which use graphene reinforced learning, and it will automatically detect object and to graph it. And in my future, I want to add some motive detection, like the table tennis robotic, which can detect your motion and make the reaction to hit the ball. That's all.
Oh, that would be a very interesting project. It would be very difficult. A colleague of mine from China, he has worked on a simple table tennis playing robot, so they can make some simple shots. Also, the German world champion was working together with KUKA, but they sort of just faked the video for him playing against the robot. But like I said, we already have world champions AI systems that can beat the human world champions in chess and checkers and Go and any other kind of game like that. But it will be a long time before we have a robot that can beat the human world champion in table tennis, I'm sure. Just to be able to move the arm fast enough with enough accuracy is a very, very difficult problem. But very interesting to work on, of course. Yes. Okay.
Thank you.
Thank you.
Thank you.
Next up, Marcelina.
Yes.
Hello. Please
Hi,
introduce
everyone.
yourself. Yeah.
Yes, I'm Marceline. I also enrolled in a Selenium course, and my university background is I got the bachelor degree of architecture in National Chengdu University. And now I'm doing my first year master student at NTU, civil engineering department. And my programming experience is just for about half year. I'm working on Python, and my IDE is use Visual Studio Code. My hobby is like photography and go hiking. So why I want to take this course is about our lab is working on deep learning, apply detect the construction site situation. So I also want to seeking for how reinforcement learning can apply on the construction site. That's all. Thank you.
Okay, thank you. Mohani 1, please unmute yourself, introduce yourself.
Sure. Can you hear me?
Yeah.
Yep. So hi everyone, my name is Jules. I come from an engineering background. I've just completed a master in what we call mathematical engineering. So back in France, my home country. Decided to specialize in studying computer vision and to pursue a PhD here at NTNU. So it's my second time at NTNU. I had the luck to do a semester exchange last year during the COVID period, the right place. So second time in your class as well, Mr. Professor Baltis. I'd say my hobbies are about the same as yours. I hope to be able to speak Chinese by the end of a few years here. And in terms of coding, I've done a lot of Python, R, MATLAB, Scala, SQL. Regarding object-oriented language programming, I've done a little bit, but I haven't had projects where I use those languages, so it's not exactly my strong suit. And I chose to take the reinforcement learning course because it's a big field in AI. I'm not sure if it's necessarily going to help me in my projects, but I really want to broaden my understanding of AI. And I think it's an important topic as well.
Okay. Thanks. So you're still in France, right? Or are you in Taiwan already?
No, I'm still in France. I'm leaving on Friday to quarantine.
Okay, yeah.
It's 2 weeks of quarantine, and another week after that we have to isolate. It's kind of crazy.
Right, yes. Okay, good. So have a safe trip then. Next up, Song.
Hello?
Hello.
My computer's microphone is broken, so I use my cell phone instead. And hello everyone, my name is Junting Song. You can call me Song directly. Can you hear me?
Yes, I can hear you.
Okay. I've been graduated from NTNU and received my bachelor degree last semester. After that, I decided to conduct my master degree here. And right now, I'm the first year student of Educational Robot Center, and my professor is Jackie Bolt. And what's next? As a student in ERC lab, I have been working around with humanoid robots since I was a junior student. I also participated in the robotics competition that Professor just introduced to us. So some of the events in the competition, like archery, sprint, and marathon, I've done these kinds of projects before. And also I have some background knowledge of machine learning before, since I took some courses related to this topic. I also have some competition experience about this research area. The reason why I take this course is that I've heard this TOEFL planning technique before, and I know it works very well in some scenarios. For example, like Go and some games. Yes, and I understand it through some trial and error methods, while I never had a deep understanding of it, which makes me be more curious about it. And besides, the senior in our lab before has applied this strategy on his project, and I think it's very cool and might be helpful to the research I will conduct here. And I accumulated my programming experience through the project I mentioned before. As for programming language, I feel more comfortable and be familiar with C++ and Python. I use Bing as my editor and Visual Studio as my IDE. My hobbies will be playing basketball and watching comedy.
Yeah.
That's all.
Okay, thank you. And then Sun. Sun, can you please mute yourself and introduce yourself? Yeah.
Okay, can you hear me?
Yeah.
Okay. Hello, I'm Sun Shen. I'm Shen Sun. I'm a master student in NTNU now. My advisor is Jackie, and I took this course last year, and I can share this course. Reinforcement is very powerful algorithm, and I am a teacher assistant of this course. If you have any question, you can contact me by Discord or my email. I will pass my email on the channel after. And before last year I took this course, we will use some kind of environment called OpenIG. It's a very powerful environment by Elon Musk. And I can for sure is useful for everyone's research, even if you use manipulator or robotics. And you have got a lot of information, even if you don't need use now. And I hope this course will make everyone happy. For sure.
Yes. Okay, so Sun is the teaching assistant for their course. If you have, he will organize submitting assignments and things like that, and help me with organizing the course. He's also a master student in the ERC. So for the rest of the course, I just want to do a short introduction to Python programming, because we have some students that have very little programming experience, and to sort of get them started in the correct setup, starting them out on the right foot, we will do an introduction to Python programming. First, I'm going to do a little poll though. So the question is, I'm a good Python programmer. If you think so, then please react with thumbs up. Otherwise, react with thumbs down. Okay, just react to the message. No need to send it as a separate message. Okay, good. So then for the little Python introduction that we're doing, I'm going to try and do something a little bit different. At the moment, I'm not going to be able to do anything. Oh, that's fine. So we're going to do a couple of small exercises, just giving the basic data structures and control flow instructions for Python. But for people that are already familiar with Python, hey, how come? Oh, I gave access now. They can go through the same exercises and can try and do them in JavaScript. JavaScript is also a dynamic language, very similar to Python in quite a lot of ways. And so if you would be bored by using Python, you can do the same thing in JavaScript. So here's a link to the JavaScript repository. And also, if you are a beginning programmer in Python or anything else for that matter, I suggest that you can join one of the Python classes. There are many available online. I think the Google Python class is quite a good one. So if you're not very confident in your programming, then you can use the Google Python class. to brush up and improve your knowledge, extend your knowledge. So where is my Python? Okay. So here's a link to the Python version that I'll be going through now. So you can follow along, or you can make a copy and make your own changes. Come on. Sometimes the Google servers are a little bit slow. So let's start with our introduction to Python. Python is a programming language developed by Guido von Rossum. He was one of the original implementers and designers of the Unix operating system. And then late 80s, he designed and implemented the first version of Python. It's the name is based on the Monty Python Flying Circus, a comedy team from the UK. So Sung should be interested in them. They are a very good example of the quirky, scurril humor of people from the UK. Many UK comedy teams are sort of similar in that sense. It started 1989, but then has grown since then in popularity dramatically, and is now the lingua franca for a lot of work for machine learning. So most of the new algorithms in machine learning are implemented in Python. Also bioinformatics, protein folding, those kind of applications use Python extensively. And also more generally AI. It's also a very popular scripting language. And if we look at the TIOB programming language popularity contest, then I thought I had it here. Then you can see September 2021, it's placed second place. It has been in the top 3 for a very long time. I'm actually looking at it. There's always slight changes about the different programming languages. Exactly how you measure popularity is not quite clear. So looking at this list, for example, then C would be the most popular language, then Python, then Java, where Python moved up a slot and Java moved down a slot compared to September 2020. And then C++, C#. I would be surprised that Visual Basic is still so popular. I would have expected JavaScript to be higher up, and then assembly language has grown dramatically. I don't know why that would be, but okay, so they moved from 14 to 8th. I assume that's the Arduino kind of programming. So another student just joined. I guess he's interested in okay. As a short description, it's a dynamic multi-paradigm programming language. Most of its approaches, most of its ideas are imperative programming methods, or an imperative programming language. It does support object-oriented programming and also some functional programming language features. Now, in order to actually do something with Python, it is best to start with a Python distribution. So we want to use the Anaconda Python distribution. You can click on the link. Anaconda is the Python distribution, which means it's a Python programming language, interpreter, editors, runtime, combined with a whole bunch of libraries. And one of the reasons why Python is so popular is that there's a lot of high quality, high efficiency, very efficient libraries that support a lot of the different kinds of applications that you may want to write a program for. One of the initial sort of advantages or initial application areas for Python, for example, was scraping the web, building a program that can go to all the different McDonald's shops or all the different convenience stores in Taiwan, like 7-Eleven and High Life and Family Mart and OK Mart, and what else have you? Go to all of their websites and then check which one of those has the cheapest orange juice. Do a price comparison, and then you can go, figure out which convenience store you want to go to. That sort of thing was done and supported by Python very well, and now there's a beautiful soup library that makes that kind of programming even easier. Similarly, for machine learning, now we have several high-quality environments for machine learning, including Keras and PyTorch, and those are built on top of the scientific computing stack that Python employs, which consists of Matplotlib and NumPy, SciPy, and scikit. Now, all of these extra libraries are very nice to use, very powerful, but the problem is to compile them and install them by hand is at the best of time a lot of work. It can also be quite difficult because you need to make sure that you use the right OpenCV library for that version of NumPy and the right version of library X to go with the version of library Y that you want to include. And so Continuum has done a lot of work to make that actually easily accessible to people. And you can download the Anaconda Python distribution. Here, if you click on that button, it's the one for your current operating system, but there are versions for Windows, Mac OS, and Linux. You want to make sure that we use that you download the Python 3 version, not the Python 2 version. But in general, yes, you would just click on the button and then follow the installation instructions. That gives you a fully equipped Python environment then. So you want to install that on your computer. Your development environments, Python, Anaconda, or Python itself actually comes with a very simple one, simple editor called idle. That's actually good enough for lots of applications, lots of development. Spider is also included in Anaconda. It's a more powerful editor. More targeted towards notebooks rather than straight up writing code. Visual Studio Code, I believe now is a optional download. So when you install Anaconda, then it'll actually ask you if you want to install Visual Studio Code. This is probably the most popular editor IDE for Python. You can, if you open a Python file, it'll ask you to install several extensions that you can install that allow you to make it easier for you to program in Python. And there's also PyCharm, which is done by a company called JetBrains. JetBrains is also the company behind Android Studio. They have several powerful IDEs that are very efficient, and lots of people like them. For PyCharm, there is an open source community version. Actually, I'm not sure if it's open source, but there is a freely downloadable version. More interesting for students is that by joining the JetBrains educational program, you can actually get a free pro version of the PyCharm and all of the other applications that JetBrains develops. Which also includes some credits for continuous integration services, DigitalOcean. So that is not a bad idea to join. me see where this guy is. Oh, okay. Okay. So now let's have a look at Python. First of all, and this is more an introduction for how to learn any kind of imperative programming language. If you understand 5 things about any kind of imperative programming language, you're well on your way to become an efficient programmer in that particular language. Most likely there will be some syntactic niceties that you wouldn't know about until you read the language details, the language documentation in detail, but at least you'll be able to write some simple programs. This is our goal for today. So I mentioned before that Python is a dynamic programming language, which means that it doesn't have a compile time, a static type system. So variables can change the type of their data on the fly, whereas in a statically typed programming language, each data item has to have a specific type, and you can usually not change that type unless you execute some casting operation or something like that. Implicitly, you cannot change the type of your data and your assignments. So let's have a look at the first example here. We define a variable. There's no var keyword or anything like that. I want to have a variable called x, and I give it the value 3. Now, if you compare it to the same version in C, then it doesn't actually look that much different, except that you would have to specify the data type. Because C is statically typed, I need to tell the compiler that this variable x holds integer variables. And so I need to go int x is equal to 3 rather than x is equal to 3, right? And then I can print out the type of the variable. Now, for some reason, this doesn't work in the Jupyter notebooks, but if you run this in your standard Anaconda distribution using Visual Studio Code, then it will print out that the x is a variable of type int. And of course, we can do the same thing with JavaScript. So let's try and see how this works with JavaScript. This is run already, so then I need to reload it. And then here I can print out a message. So JavaScript now is enabled on this particular notebook. And actually, in this case, I think I can type it exactly like Python, and it will work. Yep. And instead of calling type in JavaScript, you would call type off in order to return the data type. And the data type is slightly different. It's not labeled as an int, it's labeled as a number. Because JavaScript has really no integer data type. So you can see if I change it to a floating point number here, 3.14, then the type is still a number. So JavaScript doesn't have a data type specific for integers, whereas Python does. But other than that, it's basically the same, except that you want to use semicolons, even though you don't have to. Sometimes the code becomes ambiguous unless you add the semicolons in the right place. So it's better to put the semicolons at the end of your statements all the time. And to actually define the scope of the variable, idiomatic new JavaScript would be using a let in order to define a block scope variable. These are all details of the different programming languages, not much that you need to concern yourself about with. Most of the time, these things are hidden from the programmer. So now I can change it in Python. I can now reassign x to a floating point number. That is actually not allowed in C. I wouldn't be allowed to do that without going through a recasting, a union, passing a pointer to something and then reinterpreting that pointer. That wouldn't be possible in C. So where's my course? Did the guy join now? Yes, okay. And then I change it to a string. Operators are usually quite often overloaded, so the plus here applies to numbers and you get the addition. For strings, I can take string 1 plus string 2 and then it will give me the string concatenation. In Python, we also have a data type for complex numbers. So numbers 1.0 plus 2.3i would be a complex number often used in engineering and physics, but I is used extensively in programming already as a loop variable. So Python uses j in order to identify the imaginary part of a complex number. And apart from integers, floats, strings, and complex numbers, we also have booleans that are true or false, and then you can combine them with the logical connectors like and, or, and not. And all of these can be applied to variable x here if I want to, or some other variable. And so the type of the variable in a dynamic programming language is only of importance when we actually execute a statement. So here the type of x will only be set to string, or it'll be changed to string once I execute this particular statement here. Now the types are still important. They're not completely useless. If I have a string x and an integer y, and I ask the computer to calculate x plus y, then now it doesn't have an operator to do addition for a string and an integer. So in this case, it will throw a type error. Your program will crash. If you want to do that, you have to convert y into a string first using the string operation, the string function. So str takes a data item and converts it to a string always. So if we look at the corresponding version in JavaScript, just for fun, then I can basically write very similar code. Three x there. Okay, now, yes, so now I defined a variable. So if I declare it first, then in JavaScript, I have to write it like that, I guess. But it's already defined, so let's use a different name here. Otherwise I have to change all of that. So here I change it from a number to a string, and string concatenation. Right, so that works the same way. JavaScript, in contrast to Python, though, JavaScript is much more aggressive when it comes to casting. So if I have x is x plus then this actually works, right? Python throws an error here. Okay, how come? Here. Python throws an error here, but JavaScript just does the casting. So that seems more convenient. But let me just show you one example. I'm not sure if I can remember correctly, but if I do this, x is BA plus A. So almost. There's a way that if I execute this statement here, not exactly this one, then I actually get banana out of it, even though it doesn't make much sense, because this one here, plus plus, is an error. So when it executes it, it will generate an error, but then it's forced into a string, and because of that, it will return not a number, so nada. And then no. Yeah, and then what you actually get is no error in this case, right? This program clearly should crash because it has a fairly major syntax error, but JavaScript just gives you banana in this case. So that's why Python sticks with a much more conservative approach to casting. So unless it's integer to float, Python doesn't really do any automatic casting, because you can get into a lot of trouble when you cast things that aren't really numbers to strings. So that includes sort of the first two fundamental pieces for learning any kind of programming, imperative programming language. First one are types and variables, what kind of types you have, how to define them, how to combine them with simple operators like plus, minus, concatenation, things like that. It also is important to realize the sequencing of your commands. In Python, as well as JavaScript and C and many other programming languages, the statements will actually be executed one after another. So you have x is equal to 3, that will be executed first, then the print, then the x, then the print, then the x, then the print, so on and so forth. Other programming languages don't have this strict order of execution. So for example, in Common Lisp, if you have a con, the conditions of the conditional can be executed in any order. So you have to make sure that any possible order, any parallelization of your program will still generate the correct result. Similarly, in the mid-90s or early 90s to mid-90s, transputers were a very powerful type of parallel processor that people like to use. They were programmed in a programming language called Occam. And in Occam, you can tell that a block, any part of the program, can be executed in parallel if you wanted to. Or by default, it would execute in parallel. And that allows the compiler to be much more aggressive about the optimizations that it can apply. Similarly, lots of functional programming languages where every thing is considered to be a pure function they can, in theory, also be executed in any order. However, real programs do have side effects, and so for programming languages, for Occam, like Occam, and the functional programming languages, one reason why they are not so popular is because it's harder to reason about them, and then it's quite easy to write a program where you print out please enter a number from 1 to 5 and then read the number, right, in some command line interface. That happens quite often. But if you write this in C, then it's very easy. You just do a printf, please enter number from 1 to 5, and then scanf to read the number, and this is going to work just fine. But in Occam or some of the functional programming languages, you may get the statements out of order, which means that you read the number and afterwards you print please enter a number from 1 to 5, which is very confusing to the user because they don't know what to enter. They don't usually even know that they have to enter anything. So the sequencing in Python is intuitive and straightforward, even though that means that it's harder to optimize the program for the interpreter to make it run really fast. But it's much easier for humans to deal with that program and write correct code. The next foundational element, the next column for imperative programming is iteration, which basically means loops, the kind of loops that you want to support. Python has, or the loops that you're familiar with, the most common one is probably for I is equal to 0, I less than 8, I plus plus, which runs from 0 to 7. So it will iterate through the loop 8 times. Python doesn't really have this kind of counted loop. Python only has a loop over ranges, which is what would be called a for each loop in programming languages like C# or C++, the old version, and in the new version you would use ranged loops. For auto x in vector of integers, for example, you get every element of that vector. So to get counted loops in Python, we have to generate a container. That's done using the range function. So range can take a maximum of 3 arguments. Usually you only provide one, the stopping condition, then it'll count from 0 to n. So if you go range n, range 8, you will get sort of a fake list that includes 0 up to 7. But you can make it more complicated. So you can have a start value 0, you can have a stop value, in this case 12, and you can have an increment. So if I want to increment through the generate a list that includes numbers with an increment of 3, I can do that. The stop value is not included. So this particular loop would start at 0, then 3, then 6, then 9, then 12, but 12 is equal to the stop value, so it'll not be executed. So this particular loop would print out 0, 3, 6, 9, and then it would stop. We have a while loop. So number is equal to 15, while the number is greater than 3, then print the number. So we start at 15, 15 is greater than 3, we do an integer division by 2, which will give us 7, 7 is greater than 3, then we will go print that out. Then we go 7 divided by 2 is 3. We'll print out 3, but now 3 is not greater than 3, and the while loop will terminate. And Python has powerful methods for enumerating over containers. In fact, like I said, counted loops are just fake loops over, or loops over fake containers. So if you have a list, ABC, which is indicated by square brackets, then for x in ABC, we'll assign x the value of A, and then B, and then C. Now in JavaScript, it would look very similar, except we have curly brackets. Oh, yes, we have curly brackets to indicate our scope of the loop, the command block that we want to repeat. And then also here I can just show how to do string interpolation in Python, in JavaScript. So this gives us from 1 to 7. And that's one thing that is actually very important. As you can see, in contrast to the JavaScript, we don't have any curly brackets in Python. Python is one of the few languages where the white space is actually meaningful. So these two spaces here at the beginning of the line that indent the code, those are used by programmers all the time, right? If you write C code or Java code or C# code, doesn't matter what kind of code, you always use indentation in order to show the grouping of the statements. But in contrast to Python, your JavaScript or C or C++ compiler, in theory, you could write the entire program on a single line and it would execute. It would just be way too hard to understand for a human. So we don't do that. We use indentation. But that is actually a problem, because sometimes if the indentation and the brackets get out of sync, it leads to errors that are very hard to find, very difficult to debug, because the human basically just doesn't see them. So Python, if we have a block, like for every loop at the end, if we want to start a loop, we use a colon, and then the next line must be indented by 2 spaces. Otherwise, you will get an error, because the interpreter will tell you that there's nothing that it can actually iterate over. So indented here. Then the intention becomes very clear. Like, I didn't have to say anything, but it's by just looking at the code, programmers will easily understand that those 2 statements, num is num divided by 2 and print num, are the loop body. This is what I want to execute until the number is greater than 3. And I don't need any curly brackets in order to be able to do that. Let me try in C++. I can write a program like this one here, which looks very much the same. And I can run it, and the output is not what you expected to see. Because here you think you're running a loop 8 times. So you start with x is equal to 0. So you think that at the end of that loop, x should be equal to 24 when I print it out. But surprisingly, our output is 3. And even though this very small program, you may not be able to realize what the error is. Modern C compilers, if you turn on all the warnings, it's a little bit better because the compiler will actually tell you that there's something funny going on. So in that case, it's not that hard to realize. But the problem here is the semicolon. A semicolon in C is actually a command. It's a null command, something that does nothing. And the syntax for the for loop is that you have for, initializer, comparator, incrementer, then close brackets, and then the next statement is what's going to be repeated in your for loop. So if I put a semicolon there by mistake, then I actually have a loop that does nothing 8 times. Then the next syntactical part is a block of statements. Those I can start anywhere I want. They don't have to be following a loop. I can put them anywhere I want in order to scope variables. So I create a block of statements, and that statement is x plus 3, but that will only be executed one time because the loop is already terminated with the semicolon. So that's why you get an error of 3 here. Not what you would expect. And the reason is because the programmer would look at the indentation here, understand what the code is supposed to do, but the compiler looks at the brackets and has a completely different view of the program. So just out of interest's sake, I've never tried this in JavaScript, but we can try that. So that is equal to 0. I z is z plus 3. And then I'm even curious what this will print out. Yeah, so here you don't even get an error in JavaScript. Right? If you miss the semicolon at the end of the line of your for, then the code will run and it'll execute exactly what you tell it to do, but not what you think you told it to do. And you get an output of 3. Whereas if you look at this code, you do it 8 times, so the output of z should be 24. If I get rid of this semicolon, then it'll print 24. Yeah, because they're global scoped. So yeah. Another example of how this can go wrong is with dangling else's. So with if then else, you can also have a problem with extra semicolons or missing semicolons, changing completely the meaning of your program. In Python, that's impossible, right? Because there's no way that I can specify an error like that. If I have a colon, then this must be indented, and this is what will be repeated. there's no ambiguity, no two different views of the program. Then the next foundational element, the next column for imperative programming are conditionals, because we need to change the control flow, right? Imperative programming means that the main focus of your program is to develop the commands, the instructions that you want the computer to execute, and the order and the control flow as you execute those instructions. So that's why you need loops and conditionals as the main building blocks for your program. So in Python, you have the if then else. There's not much surprising there. So you can have a variable 9, and then if it's less than 15, again, you open a programming block here. So there must be a colon, and the next lines are indented by at least 2 spaces. 2 spaces is the sort of default, but you can also use 3, 4, or 10 spaces if you want to. Then your code will just shoot off to the right side a lot faster. But the exact number of spaces is not important, just has to be more than 2. Then if the value is greater than 6, I can print that this is between 7 and 14, otherwise it's smaller than 7. And then where my block closes, I need to align it correctly. So this else has to be underneath this if, because it matches that if there. And then value is larger than 14. If I print that out, not much surprise there. There's one special thing about conditionals in Python, and that is if you look at the code and you have else if all the time, your code will continue to be pushed to the right hand side, like here. If I want to check which direction the player wants to move, then if they press the up key, I want to move up. Else if they press the down key, I want to move down. Else if they press the right key, I want to move right. Else if they pressed left. So you can see that the indentation here increases, right? Because every time I start a new block, and every time I start a block, I need to indent by 2 spaces. So I have no choice there. Python provides an else if, which combines the else and the if into a single statement, and then you don't need to add any further indentation. So that makes writing code that does a lot of comparisons nicer to read, because now everything is in one column. However, this program here will also work. This is not wrong. It is just not idiomatic Python. It's one of the else if is one of the syntactic features, syntactic sugar people call it, to make writing these kind of programs easier. So now let's have a look at advanced data structures that are included in Python. So lists there's no arrays in Python. Lists are the closest thing that we have to arrays in Python. They're like much more powerful versions of arrays. And even though they're called lists, they're not actually implemented as single or double linked lists. They're actually array lists, which is the most common form of doing lists. Even the C++ standard library now uses blocks of arrays in order to do linked lists, because it's much more efficient on modern processors. So you define a list by using square brackets. Here's the opening bracket, and then you can put arrays into elements into it, separating them by comma. So here we have 1, 2, 3, 4, 5, 6. The elements, the data types in the list, since Python is dynamic, they can change. So they can be any data type that I want. So I can go from int to floating points to strings. So the next element is 6, then 4.5, then the string Joe, then the string Bob, then the string Bill. And my next element is actually an entire list that I can put into a list. So this is a list within a list. That list has A10, B20, C30 inside of it. And then I have 8 and 9 at the and then the closing of the list. So now what can we do once we have the list? Well, we can retrieve elements from the list. Lists, like arrays, are 0 indexed, and we use the square bracket notation. So list 0 would be the element at the 0th position of this list, which would be 1. So this would return 1. Then often we need to know the size of the list. So in Python, that's list length. Now, list -1 in Java and C++, if you use the right accessor, that would throw an exception. That would tell you that it's an array out of bound exception. In Python, in C, it would silently generate an error, which is one of the reasons that makes C a very insecure programming language. If you have any kind of bug that allows a user to control an index that you calculate into an array, they can basically read the entire memory of your running program by just using different offsets. They're not limited to the array memory. In Python, this is actually a legal statement, and the semantics are that -1 would be the last element of the list. So it's a quick way to get the last element of a list. The first and the last element of the list are always accessible in constant time for a Python list. So that can happen very quickly. And list -1 is basically the same as list index at the length of the list -1. So the first line there will print out 1. I'm getting the 1 here. 13. There's 13 elements in the list because this entire thing here is just one entry, right? This whole sublist only counts as 1. And list -1 gives us the last element, 9. I can extend that. I can do list -2, which will give me the 8, the one prior to the last element. And then another powerful feature of Python is that I can extract lists, sublists from a list. So lists from 3 to 6 are the elements at index 3, 4, 5, and up to but not including 6. So 3, 4, 5, the elements would be index or element at index 3, I have element 4, right? 0, 1, 2, 3. So that gives me the 4, the 5, and the 6. That is returned as a sublist, or the list -4 to -1. That will give me the element 3 before the end, 4 before the end, Bill, then the sublist, and then the 8, but not including the -1. So the last element, -9, is not included. same. One thing that is that may be confusing, that people sometimes expect to work, but it actually doesn't, is it doesn't do any reversal of the list. So the list from -1 to -4, you may think that that should be 9, 8, then this sublist, but not including Bill. But surprisingly, this would include a reversal of the list, right? But the Python, we just check if the start element, if the current element is past the stop element or equal to the stop element. If it is, we're finished and we return the list with the elements that we constructed so far. So the list from -1 to -4 will not give you an error, but it'll give you an empty list. Right? Because -1 is already past -4. The same thing as if I try to write list from 4 to 2. Right? That will also give me an empty list. And we also have another other types of powerful data structures. Dictionaries are like hash maps in C++ or Java. So I can assign key value stores to a variable. So here I have a dictionary that is indicated by using curly brackets, where the key Joe is assigned with the value 20, key Bob is assigned with the value -5, Mary is assigned the list. So if I want to be, this is the money that I owe people, then I owe Joe $20 and Bob owes me $5 and Mary owes me $3 and $4 Taiwan dollars. And the keys don't all have to be strings. I can change them, so I can use any kind of hashable data item as a key. So here I can use an integer. 234 is a dummy entry. To print out the values in this dictionary, I can use the square bracket annotation and provide it with the key. So Joe will print 20, D234 will print dummy. And another data structure that is quite useful, especially for returning values from functions, are tuples. Tuples are like read-only lists. They're in fact exactly like lists, except that in a list, if I have a list 1, 2, 3, and I set the 0th element to 5, then that will give me a new list which has 5, 2, 3 in it. But if I have a tuple which is indicated by round brackets, then I cannot change the value. So if I now try and change element index 0 to 5, then I get an access violation exception. Lastly, we have sets. By using curly brackets, I can then generate. This is sort of piggybacked on the syntax for dictionary. So now I have keys only with no values, but every key must be unique in the dictionary. So there can only be one. So I have 1, 3, 4, 5, 2, 2, 2, 2. Then if I print that as a set, I only get 1, 2, 3, 4, 5, because the multiple 2's here are all combined into a single one. So this is sometimes useful if I just want to if I'm sure that every element should only occur one time in my data collection. So in computer vision, if the different elements from your object detection, different features, if you just want to record whether they occurred or not, then you can simply append 1133 so on and so forth, and then at the end you'll just get a list of all the features that actually did occur at least once, but they may have occurred 100 times, but you don't care about that at this point. So here's another example of loops and iteration and semantic indentation. So here I have a list: Tom, Mike, Judy, Martha, and then for every element in that list I want to print it out. Modern C++ would look very similar to that, right? For auto E, vector, print out element E. And if you will need to iterate over a list or actually generate the numbers, then you need to use the range function. And here's another example using a while loop. So in this case, I need to check a condition. I want to see how far that particular list is monotonically increasing. So 4, 5, 6, 7, 12, always getting bigger, but then when we go from 12 to 3, now the numbers get smaller. So this condition here will be false and our loop will terminate. So here then I print out 4 is less than 5, 5 is less than 6, 6 is less than 7, 7 is less than 12, but 12 is not less than 3, which is why that loop terminates in this case. And here another example of a conditional about ages, young people, middle-aged people, or shirt sizes, small, medium, large shirts. Now, the last step that I want to discuss today is just the definition of functions in order to modularize your program. This is how you would define a function in Python using the def keyword. And then again, we have the colon so that we indent the next line by 2 spaces, and then this will be our program, our commands that we execute as part of this function or subroutine. We have 2 parameters, x and n. Those I pass in when I call the function. They are not typed, just like the rest of Python. So I can pass in any kind of operator. And Python, for functions and subroutines, it uses what's called duck typing. The basic idea is that you don't check whether the types of your arguments and then proceed. Usually you simply start executing the statements, and if the statement succeeds, then it's of the correct type, and if it didn't succeed, if it threw an error, then it was not the correct type. So here I define a little function called power to generate, which is actually built into Python, but we can just define one, x and n, and then I return x to the power of n. And then I can call it using the standard round bracket notation. We'll talk about classes next time. Just as an example for duck typing, here is another version, very similar. We do mult. So I call x multiplied by n, and I return that. So then if I call mult of 4 and 3, then I expect the output to be 12, right? 4 times 3. If I pass in 2.5 and 0.5, then I expect 1.25 as the output. So I can pass in integers or floating points. Those will work. More surprisingly, I can also call the same function now with a string and an integer, and that also works. So there's no test here saying if type x is equal to int or type x is equal to float, then execute it, otherwise throw an error. That would be not the, that's possible, you can write that program, but it would not be considered good Python programming. It would not be considered idiomatic Python programming. As long as the operation succeeds, you call the right function. So ha 10 times will return ha 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 10 times. So this is an example of duck typing. And it's based on a joke by the Marx Brothers. If it quacks like a duck and walks like a duck, then it is a duck. So we do not check type of arguments, but try and execute instructions and catch errors if they occur. So the reason for that is a little bit technical. I guess one reason is that because Python by default passes lists as references, not as the, because lists can be quite large, right? So it will not make a copy, it'll pass a reference, a pointer to that list, similar to same as Java and C++. So for efficiency's sake, that's a good theory, a good approach. And if I have a list in Java or C++ and I say it's a list of integers, then the only thing that can be in there is an integer, right? So I can cast it to an integer. But in Python, it could be anything, right? I can change it from integer to a string because all the data items are dynamic. And Python also supports, like other programming languages, modern programming languages, it also tries to make good use of processors. That means that you need to have code that runs multi-threaded and in a shared memory environment. So that means that there could be another thread that changes your list. So if you think about that, we have a list. One, two, three. Then I call function with that list, right? So now in my function, I could write something like if L0 is if type L0 is equal to int, and type L1 is equal to type int then return x plus y, right? That's something that I could write. But if L is a list and it's passed by reference and I have a program with these 3 lines, then let's say I'm executing this code. So now I'm executing statement 1, statement 2, statement 3, and then statement 2, and it succeeds. Then I switch to thread 2. So now thread 2 executes list of 0 is equal to Jackie, right? Then I switch back to thread 1. So in that case, now I will execute line 3, but that will be now result, and let's make that a power. To x to the power of y, but now x has the value Jackie and y has the power 4 or 2. So now this will cause an exception. So the point being that there's no point to check, because if you have a dynamic programming language, if you check the types, even if you check the types before you execute them, if you have a dynamic programming language, then the data items could change between when you check and when you actually execute it. Now, there's 2 solutions to it. One would be use some synchronization, like mutex or semaphores or spin locks, right? To have a critical section, but that will make your code run very fast, very slow, since you now disallow a lot of options of possibilities for running things in parallel. Now you're forcing things to run sequentially, which means that you might as well not bother having separate threads then often. And the other solution is basically the Pythonic approach, duck typing. Just try it and see if it worked. Because errors are always going to happen if they do occur like that, and then you have to deal with them somehow. There's no way to, even if you check everything in advance, there's no way to guarantee that by the time you actually execute, that the conditions are still the same that you checked. It's similar to programming. In the old days, you would write code like if file.exists my file our data is equal to file.open my file. So you check if the file exists, otherwise you print error, file does not exist. This is what's nowadays also called an anti-pattern. You don't want to write code like this anymore, or it doesn't make sense. In a multi-user, multi-process environment, because if you execute line 1 here and the file exists, then in a multi-user, multi-process, multitasking operating system, there's nothing that says that there could not be another process that starts executing and deletes that file before you have a chance to execute this statement here. And if that happens, then your entire check was useless, right? You would still have to catch the exception. So instead, you do something like try open my file .read. Accept, and then you can catch the different kinds of exceptions. So except E if E is file not found, print error file not found, else if E is file IO, then you can print other errors here. This is, if you had written this kind of program in the 1990s, then your teaching assistants would have marked you down, but in 2000, with multitasking operating systems being everywhere, even on your little microcontroller, you have multiple processes running. This approach is the more robust one and the correct one to use in a sense. Okay, good. Then that's it for today. The Python notebook link I will post here. And I will see you all next week. The first 3 weeks of classes are online, and then we will have face-to-face classes.